Okay, let's start with the homework. We've done Newton's second law. We've done the sample problems in the textbook from Newton's second law. We've done 4.1, second law. We've done the equation. We've done 4.1, 4.2, 4.3, and then 4.4. All of them relatively tricky. And then we're going to get into, in the textbook, 4.4, Newton's third law of motion. But before we do so, let's go do the homework questions from Newton's second law of motion, which is section 4.3. And so we find some essay-type questions, concept questions, and those are good. And then we get to the math questions, the one with the dots. Excuse me. So let's pick a couple of these. Number 23. What is the mass of an object that accelerates at 3 meters per second squared under the influence of a force of 5 newtons? Okay, well, simple algebra should give you that one. Let's try 25. A loaded Boeing 747 jumbo jet has a mass. They give you the mass. It's equal to 2.0 times 10 to the 5 kilograms. What net force? They're looking for force required to give the plane an acceleration. Acceleration is 3.5 meters per second squared. Again, that's a straight plug-in, no algebra even required. We'll do 27. What is the mass of a person who has a weight of 740 newtons on the Earth? Well, they only give you one bit of information here, but they give you the hint it's on the Earth, and on the Earth you know the acceleration due to gravity is 9.8 meters per second squared. And so the formula for weight is weight equals mg. So W divided by J gives you M. 27. 29. What is the weight of an 8 kilogram per mass in newtons? How about in pounds? Okay, so they give you the mass, 8 kilograms. They ask for the weight in newtons, and acceleration due to gravity is 9.8 meters per second squared. Weight equals mg, and that returns an answer in newtons. And then the conversion to pounds was one of the sample problems, how to convert from mass to pounds, and we did that together. Question 31. A product label, 16 ounces, 1 pound, 454 grams, or 0.454 kilograms. Is this label correct on the Earth, on the Moon, where the accelerator's gravity is 1/6 that of the Earth, in deep space where there's little gravity, or all of the preceding? Well, it tells you the weight, well, it tells you the mass, so that's going to be true no matter where you go in the universe. It tells you the weight, and that really has to be on Earth. What mass of lasagna would a label show with the amount that weighs 2 pounds on the Moon? Well, 2 pounds on the Moon, if it's 1/6 Earth, if it's 2 pounds on the Moon, that makes it 12 pounds on Earth. And 12 pounds on Earth, they want to know the mass. And so now you have to convert 12 pounds to mass, and once again, that was the sample problem. Love those sample problems, don't you? Let's do 33. Now we're getting into a homework problem worthy of college physics. A horizontal force of 12 newtons acts on an object that's at rest, which means velocity initial is 0. Force is 12 newtons. Frictionless surface. Where the object has a weight, the weight of this object is 98 newtons. Now remember, as soon as I tell you weight, you can go find mass. Sorry, I'm doing this down here. They give you the weight of 98 newtons, you can find the mass. The mass is weight divided by gravity. So you also know the mass of this thing. Let's see. What is the magnitude of the acceleration of the object? So you find mass from this statement. You plug it in. Now we've got force and mass. You find acceleration. What would be the acceleration of the same object in a similar situation on the moon? Well, on the moon, what would be different? Well, its weight would be different, but wouldn't its mass be the same? And if I push horizontally, I'm not trying to lift it against gravity, so I don't care about its weight. So whatever the force is, which would be the same, and whatever the mass is, which would be the same, will produce the same acceleration. All right, there's a few of the homework problems from that section.